Good evening, children. I hope everyone are doing fine. So let us continue with the chapter acids, bases and salts. So we had a test in between, so I couldn't continue with the chapter. So next topic that I'm going to do today is what do all acids and all bases have in common? Okay, so let's begin. One thing that commonly seen in case of acids and bases are acids or base solution. So if you allow it to react with water, it conducts electricity. So that is one common thing. For that you have a small experiment. You can see it in the picture and also in the textbook it's given activity 2.8. So we need to take some solutions of glucose, alcohol, hydrochloric acid, sulfuric acid. Okay. And we need to fix two nails on a cork and we need to place the cork in a 100 ml beaker like how you see in the picture. And you need to connect the nails to the two terminals of 6-volt battery. We need to use 6-volt battery through a bulb and a switch as shown in the picture. Okay, now we need to pour some dilute HCl, that is hydrochloric acid, in a beaker and switch on the current. And we need to repeat with dilute sulfuric acid and we need to observe. And we need to repeat the experiment separately with glucose and alcohol solution and do the observation. And we should see that whether the bulb glow in all cases. Okay, so what happens is the bulb will start glowing in the case of acids. Okay, but we'll observe that glucose and alcohol solution do not conduct electricity. And glowing of the bulb indicates that there is a flow of electric current through the solution. And the electric current is carried through the acid solution by ions. So we know that acid contains H plus ions as cations and anions such as Cl minus, right? And in case of HNO3, NO3 minus, H plus, isn't it? In case of H2SO4, it is H plus, H2 plus and SO4 2 minus. And in case of CH3COOH, it is CH3COO minus and H plus. Okay. So since the presence of positive ions and negative ions, they conduct electricity. Okay, so this suggests that acid produce hydrogen ions, that is H plus aqueous in solution, which are responsible for their acidic properties. Okay, and we need to repeat the same activity using alkalis such as sodium hydroxide, calcium hydroxide. So that are the bases that do not conduct electricity, right? Yeah, they do conduct, but not as such in a acid. Okay, so we have seen that all acids have similar chemical properties. So what leads to this similar in properties? So just now we saw an experiment which shows some similar properties, that all acids generate hydrogen gas on reacting with metals. So hydrogen seems to be common to all acids. Okay, and even in bases we can see OH, H plus ions, right? So next we shall see what happens to an acid or base in a water solution. So coming to what happens to an acid or a base in a water solution. For this again we have one small experiment or activity to perform. So what do you think, children? Do acid produce ions only in aqueous solution? For that we need to test this. Okay, we need to take about 1 gram solid NaCl, that is sodium chloride, in a clean and dry test tube and set up the apparatus as shown in the figure, that is in a picture. And we need to add some concentrated sulfuric acid. Be careful when we are using this concentrated sulfuric acid. So this has to be performed in the presence of teacher. Okay, so we need to add some concentrated sulfuric acid to the test tube. Okay, and what do we observe? So we should observe what is the reaction taking place. So is there a gas coming out of the delivery tube. Test the gas that is evolved successively with dry and wet blue litmus paper. So whatever the gas is evolved from the reaction, we need to test it using a dry and wet blue litmus paper. Okay, so in which case does the litmus paper change its color? So on the basis of this activity, so what we infer about this acidic character of dry HCl gas or HCl solution. So if the climate is very humid, so we will have to pass the gas produced through a guard tube, that is drying tube containing calcium chloride to the dry gas. So this experiment suggests that hydrogen ions in HCl are produced in the presence of water. So the separation of H plus ion from HCl molecules cannot occur in the absence of water, because water is responsible to dissociate two different ions, that is H plus and minus ions, Cl minus ions. Okay, so hydrogen ions cannot exist alone, but they exist after combining with water molecules. Thus, we can say that hydrogen ions must always be shown as H plus aqueous or hydronium ions, that is H3O plus. Okay, and when we see that acid gives H3O plus or H plus aqueous ion in water, so now what happens with the base when it is dissolved in water? For example, we have taken as NaOH, that is sodium hydroxide. You can see hydroxyl group, that is OH. So when we allow to react with water, okay, so it dissociate to Na plus aqueous and OH minus aqueous. Okay, so like that we can perform with KOH, K plus aqueous and OH minus aqueous, and magnesium hydroxide MgOH2. Okay, it gives out as Mg2 plus and OH minus. Okay, bases generate hydroxide, that is OH minus ions in water. Bases which are soluble in water are said to be alkalis, right? So alkalis are nothing but group 1 elements. So how strong are these acids or base solutions? So we know that acids are the chemicals which dissociates into H plus ions when it is dissolved in water. Right? For example, HCl, when we allow it to react with or dissolve in water, so what is the dissociation? A dissociation process takes place. It splits up into H positive and Cl minus, right? And what about H2SO4 in case of water? So it is H plus then HSO4 aqueous, right? So this definition helps to decide the strength of an acid. So the more will be the H plus ion dissociated, the stronger will be the acid. So in case of HCl is a strong acid now because H2SO4, it is giving out HSO4. Again, H is attached to SO4. So the dissociation of H is less compared to HCl. So the dissociation of H plus ion in water depends on the strength of the bond between hydrogen and other component. So the bond is strong in case of HSO4. So we can say that HCl is stronger than H2SO4. What about the strength of base? So we already know that bases are the chemicals which dissociates into OH minus ion when dissolved in water. Examples are NaOH, KOH, NH4OH. That is a weak base. Why we say it as weak base? Same knowledge applies here also. So dissociation of H plus ion matters a lot here. Okay, in case of NaOH, so hydroxyl, that is OH, H is dissociated at once. Okay, in case of NH4OH, it takes some time. So we call it as weak base. So Na and K are said to be alkali metals, that is group 1 of the periodic table. So alkali metals are nothing but, if you observe the periodic table, you can see all these alkali metals are arranged in the group 1. Okay, alkali metal of a base are very strong in nature. Okay, simultaneously, the more will be the OH minus ion dissociated, the stronger will be the base. So children, strength of an acid or base. So can we quantitatively find out the amount of H plus or OH minus ions present in a solution? Can we do so? So can we judge how strong a given acid or a base? Yes, we can do this by making use of a universal indicator, which is a mixture of several indicators, like how we studied about few indicators in the previous class, like phenolphthalein, isn't it? So all this different mixture of indicators is present in universal indicator, which is going to indicate whether the given solution is a acid or a base. So the universal indicator shows different colors at different concentrations of hydrogen ions in a solution. Okay. So here in the picture you can see variation of pH with the change in concentration of H plus aqueous and OH minus aqueous ions. So here you can see acidic nature increasing, that is 0 to 7. So 7 is said to be neutral. Okay, that is H plus. So whatever the solution which comes under the value between 0 to 6 or 7, that is said to be increase in H plus ion concentration. So there is a dissociation of H plus ions more. Okay, in case of base, that is hydroxyl, you can see decrease in H minus ion concentration. Okay, so 7 to 14. So basic nature increasing. So N7 is said to be neutral, that is water. Okay, so this is about variation of pH with the change in concentration of H plus aqueous and OH minus aqueous ions. So now we are going to study about pH scale. This is a scale for measuring hydrogen ion concentration that is there in the solution. So how much concentration of hydrogen ion is there in the solution, that can be checked to pH scale. So that is said to be pH scale. The P in pH stands for potence, that is a Greek word, potence in German. So meaning is power. So power of hydrogen. On the pH scale, we can measure pH generally from 0, that is very acidic, to 14, that is very alkaline. So pH should be thought of simply as a number which indicates the acidic or basic nature of a solution. So higher the hydronium ion concentration, lower will be the pH. That means pH is inversely proportional to hydronium ions. Okay, so the pH of neutral solution is 7. So values less than 7 on the pH scale represents an acidic solution. As the pH value increases from 7 to 14, it represents an increase in OH minus, that is hydroxyl ions, so concentration in the solution. So that is increase in the strength of alkali. Okay, so generally paper impregnated with the universal indicator is used for measuring pH. Okay, so in page number 26, so there is a table, table 2.2. So where they have given solution and we need to find out the color of pH paper, approximate pH value and nature of substance. So like saliva, so before meal, after meal, what is the pH, and lemon juice, colorless aerated drink, carrot juice, coffee, tomato juice, tap water, and one mole of NaOH and HCl. So we need to check the color of pH paper. So what is the pH value? For all this, we need to check. Okay, so we have an activity that is 2.11. Test the pH values of solution that is given in the table just now I mentioned. Okay, so let us see pH of some substance shown on pH paper. So examples we will see out. And one more thing, the strength of acids and base depends on the number of H plus ions and OH minus ion produced. So as I mentioned in the previous slide, so if we take hydroxyl acid and acetic acid of the same concentration, say 1 molar, okay, then these produce different amounts of hydrogen ions. Okay, so acid that give rise to more H plus ions are acid to be strong acids, and acids that gives less H plus ions are said to be weak acids. Okay, so just that is the reason I mentioned. So pH is inversely proportional to hydrogen ions. Okay, so acid that gives rise to more H plus ions, if it is giving out more H plus ions, then we can say that it is a strong acid, and acids which give less hydrogen ions are said to be weak acids. Okay, so let us see with examples. Yes, here you can see pH value for exam along with the examples. So pH 14. So we can say that liquid drain cleaner. Okay, so that is the bleachers or liquids that we use to clean. Okay, so pH will be approx 14. Okay, and bleaches, oven cleaner and light pH will be 13.5. So ammonia solution pH is 10.5 to 11.5, and baking soda it is 9.5. It is highly basic, right? And seawater, it is also a base, so pH will be 8. And blood, so pH is 7.4. It is something like neutral. And milk, urine, saliva, pH will be 6.3 to 6.6, slightly acidic, right? Acidic. So black coffee pH will be 5. So grapefruit juice, soda, tomato juice, all these have pH of 2.5 to 3.5, isn't it? Lemon juice, vinegar, so pH is 2. Battery acid, hydrochloric acid, pH is 0. So acidic nature starts from 0 to 6 and bases from 7 to 14. So neutral will be 7. Okay. So pH is very important. So importance of pH in everyday life. So this we have studied when I was explaining about neutralization. Okay, so neutralization in everyday life. So that is also linked here. Okay, so again I'm going to revise that topic. Okay, so are plants and animals pH sensitive? Yes, of course. Okay, so always our body works within the pH range of 7.0 to 7.8. Okay, so living organism can survive only in a narrow range of pH change. So when pH of rainwater is less than 5.6, it is called as acid rain. Okay, when acid rain flows into the rivers, so it lowers the pH of the river water. Okay, why? Because water neutralizes the acid, and the survival of aquatic life in such rivers becomes very difficult. Okay, so acids in other planets. So acids are present in other planets. So the atmospheric of Venus is made up of thick white and yellowish clouds of sulfuric acid. And do you think the life exists on this planet? No. Okay. So what is the pH of soil in your backyard? So we need to check the pH of the soil. So as I said in the beginning classes, farmer usually test their soil, the land soil where they usually cultivate the crops, they get chucked with the pH of soil. So plants require a specific pH range for their healthy growth. So to find out the pH required for healthy growth of a plant, so we need to collect the soil from various places and check the pH in the manner like we need to take 2 grams of soil in a test tube and we need to add 5 ml of water to it and shake the contents of the test tube, and we need to filter the contents and collect the filtrate in a test tube and check the pH of this filtrate with the help of universal pH indicator like you saw in a previous slide. So what can we conclude about this ideal soil pH for the growth of the plants in the particular region? Okay, so plants usually they can't tolerate there, so there are a few plants they require slightly acidic nature of the soil, and there are few plants they don't require acidic nature of the plant. So we should need to check the soil pH of soil, and then we should proceed with the cultivation of crops. Okay, so pH in our digestive system. So we know that our stomach produces hydrochloric acid and it helps in the digestion of food without harming our stomach, right? And during indigestion, what happens? The stomach produces too much of acid and this causes pain and irritation, isn't it? So to get rid of this pain, what we use is we use a base called antacids. So it is such a remedy uh, that is suggested. Okay, so these antacid that is a base which neutralizes the excess of acid. Like for antacids can be milk of magnesia, that is magnesium hydroxide, and a mild base can be used for this purpose. And pH change, if there is a change in pH, it causes a tooth decay in our mouth. So we know that our saliva consists of salivary amylase. Saliva is responsible for the digestion, isn't it? Tooth decay always starts with the pH of the mouth when it is lower than 5.5. Okay, so tooth enamel. So we have a tooth enamel which is made up of calcium hydroxypatite, that is a crystalline form of calcium phosphate. Okay, so this is the hardest substance that is present in the body. It does not dissolve in water, but it is corroded with the pH in the mouth if it is below 5.5. So bacteria present in the mouth produces acids by degradation of sugar and food particles which is remain in the mouth after eating. So that is why we suggest you to brush your teeth before you go to bed. So that is after a meal we need to brush our teeth and sleep. So that is the best way to prevent this is to clean the mouth after eating food. So we use toothpaste to brush our teeth, right? So which are generally basic. So for cleaning the teeth can neutralize this excess of acid and prevent the tooth decay. Okay, and self defense by animals and plants through chemical warfare. So this is also uh, one of the what importance of pH. Okay, so we often get stung by a honeybee, right? So bee sting leaves an acid which causes pain and irritation. So or ant bite. Okay. So use of a mild base like baking soda on the stung area which gives relief. Okay. Stinging hair of a nettle leaves inject methanoic acid that causes burning pain. Okay. So nature provides neutralization options. So how? Nettle is a herbaceous plants which grow in the wild. So it is seen in the forest, wild places. Its leaves have a stinging hair, okay, so which cause painful stings when we touch accidentally. So this is due to methanoic acid which is secreted by them. Okay, so a traditional remedy is rubbing the area with the leaf of dock plant, DOCK, dock plant, which often grows beside the nettle in the wild. So can you guess the nature of this dock plant? Yes, of course it will be a basic. So next time when you look out for if you accidentally touch a nettle plant while trekking or somewhere you are going in the forest. So also know about this dog plant, so which acts like a basic and it neutralizes the nettle methanoic acid which is secreted by nettle leaves. Okay, so be aware of it. And some naturally occurring acids, so we have a table 2.3, go through it. Okay, so next I'll be taking with the topic more about salts so that the chapter will be completed. So children, I hope everyone had followed today's concept. Worksheet will be sent along with this video on the same content. Do solve it in your homework. Okay, and next topic is about more about salts. So if I complete that content, so the chapter is completed. Okay, see you all. Have a good day.